Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating article challenging common assumptions about Rails app performance. It's titled, The Mythical Iodine Monoxide-Bound Rails App, and it's a real eye-opener. Let's get started.
I'm eager to hear this. The title itself is intriguing. Is it arguing that Rails apps aren't as iodine monoxide bound as people think?
Precisely. The article argues that while database bottlenecks are common when scaling, this doesn't automatically mean the app spends most of its time waiting for I/O. It's a crucial distinction. Many conflate scalability with performance, throughput with latency.
Right, scalability is about handling more users, not necessarily faster response times, correct?
Exactly. The author points out that Rails, being stateless, scales horizontally easily. The real scaling challenge usually lies with the database, which often requires vertical scaling initially, and eventually sharding. That's the bottleneck, not necessarily slow database queries themselves.
So, the common performance issues in Rails, like missing indexes or n+1 queries, are actually bugs, not inherent limitations?
Yes, they're solvable problems, not fundamental characteristics of the framework. When properly optimized, database queries are often incredibly fast, fractions of a millisecond. The author uses the effectiveness of YJIT as evidence. Remember those impressive speedups reported by Discourse, Lobsters, Basecamp, and Shopify?
Oh yes, those significant latency reductions. If the apps were truly I/O bound, wouldn't YJIT's impact be minimal?
Precisely. The substantial improvements suggest a significant portion of execution time is spent in Ruby code itself, not waiting on I/O. The author even suggests that CPU starvation can often mask itself as I/O wait time.
How so?
Standard I/O timing measurements often include the time spent waiting for thread scheduling, garbage collection, or the OS scheduler. This makes it difficult to isolate the actual I/O time. It's a subtle but crucial point.
So misinterpreting this can lead to overestimating I/O bound nature and deploying with excessive concurrency, potentially worsening latency. That's a clever insight.
Absolutely. The article emphasizes that CPU-bound and I/O-bound workloads don't mix well. For smaller projects, it might be tolerable. But as you scale, separating them becomes crucial. Microservices help with this.
I see. And the article also addresses background job runners like Sidekick, which are often more I/O intensive. Even there, overconcurrency can hurt performance.
Exactly. The author highlights the importance of understanding the I/O to CPU ratio to choose the right execution model. Asynchronous for truly I/O-bound apps, threaded for I/O-heavy apps, and process-based for apps that aren't heavily I/O-bound. This even influenced Rails' decision to reduce Puma's default thread count.
It's a compelling argument for paying attention to Ruby's performance, even if the database is often the initial scaling bottleneck. The author's point about API design impacting performance is also important.
Absolutely. The article concludes by emphasizing the need to balance developer happiness with performance considerations. Usability and performance aren't mutually exclusive. Well, that's a wrap on the Mythical Iodine Monoxide-Bound Rails app. A thought-provoking read, wouldn't you say?
Definitely. Thanks for breaking it down. A great discussion.
You're welcome. And to our listeners, thanks for tuning in to Tech Bytes and News. Have a great day, and we'll catch you next time. Goodbye.
Bye-bye.